Hi, welcome back. Well, I will continue with the little math part of today's class. I was talking on the relations. And as I said, relation is relating numbers that are representing a particular variable to the numbers representing another variable. Well, this is actually a case where you can see a relation. And note that the way we define the relation here is mathematical. This mathematical definition of the relation might be useful, might represent the real world, but it might also not represent the real world. So relations have a life in the realm of math in a way. They might be meaningful or they might be useful to understand, to represent what exists also in the non-math realm. So, the example I give is the relation between ages of the children, let's say, and the height of the children. Well, my relation relates every age represented in a whole number to a height, which might be an average height. For example, for 1 we have 30, for 2 we have 35, for 3 we have 38, for 4 we have 40. So if this, so in that sense, my this whole table might be my relation. If the table is my relation, in that case, I don't not the rows of the table are not a relation, but when they come together, they form a relation, because the relation should relate all numbers that represent age to the height, not only one number. So, as I said, in that sense, the whole table might be a relation, but a row of a table is not a relation, cannot be a relation. So, a relation can also be expressed in a formula. For example, we do it this way. Okay, height is equal to 25 plus 5 times h. So this formula is representing a relation, because using this formula I can find for any age. For example, I can put 1 here, multiply it with 5, which is 5, add it to the 25, which is 30, and find the height. So for any age, any number representing age, using this formula I can find a height, which means this formula is a relation. So lastly, I might also have graphs as a relation, because using this graph, on this graph, this curve you see might represent age-height relation, and using this curve I can find for any age, for example 2, a particular level of height. So in that sense, this curve connects all numbers that are representing age to the height. So this curve is also a relation. So I think all of you have seen the Echo 101, and their demand and supply are basically relations. So and many other models in the economics have relations in themselves. So either with knowing it or without knowing it, you already have learned many relations while you were studying economics, basically. So let's go down And let's now go to the starting point of the indifference curve. The indifference curves, basically. So the starting point of the indifference curves are the relations with three variables. How can we have relations with a three variable? Let's go to our original relation. This is 4 and plus. Now we have another factor, 0.000. Income is usually high, that's why I have a multiplier that is small. 0.1 times income. Well, for example, in this case, if we have anyone who has age as 1, which is 4 times 1, plus as an income also, let's say $10,000 per year, which is in the United States a very low income, by the way. The height will be 25 plus 4 plus 1, which is equal to 30. So basically my relation relates any when I have any two numbers, age and income, these two numbers are related to the height. And so now, as an input, I need to provide two numbers to get my third ultimate number. So this is the case of relations with three variables. Relations with three variables can be expressed in three-dimensional graphs. Finding, for example, this is a utility and these are two different goods, x and y. Finding for each x and y, I have a particular utility level, which is represented by the height in this case. But of course, in the two-dimensional area, we cannot draw three-dimensional graphs easily unless we have we are able to rotate our graph. I mean, we don't have a fixed graph, but a moving graph, kind of. But a way to represent three-dimensional graphs on two dimensions are the indifference curves. So we have a graph like an XY graph, which might be which are our inputs. In our case, it might be income and, for example, height. Well, basically, lines on which the third variable is constant. In this case, height. So on each of these curves, the height is constant, and we see what are the age-income combinations that give us this height. So the lowest one is 30 inches. So if you have, if you are 1.3 years old and your family's income is $1,200, then your height is 30 inches. If your age is 1.1 year and your family income is, let's say, $1,700, your height is again 30 inches. Similarly, this is true for other numbers also. If you're 1.3 years old and if your family income is $32,000, in that case your height is 32 inches. Or if you are 1.1 years old and your income is $32,000, then you get 32 inches. So, lastly, what is slope? Slope is basically shows us slope of a curve, especially how much one variable should change in a slope of an indifference curve. We are talking of a slope of an indifference curve. Slope is basically the steepness of this graph. I mean, how steep this is, and you measure it by looking to how much height is changing when the length changes by 1 unit. Here, let's say our 1 unit is 0.1. So when we change the h, decrease h by 0.1, how much will the height increase? Actually, it is opposite. How much will height increase when we increase the h by 0.1? Of course, our height doesn't increase but decrease, which means our slope is a negative slope. This curve is a negative sloped curve. Well, in this case, our slope also gives us how much should our income change when we increase h by 1 unit, which might be 0.1 year, to keep our height constant. That's our slope. So in case of an indifference curve. So how much one variable should change to compensate 1 unit change of the other variable to keep our third, the variable we're interested in, constant. So that's what slope is. A curve is more flat when slope is smaller. In that case, I mean, in order to compensate 1 unit change, you need to have a smaller change in the second variable that is represented by the height. A slope might be more steep when, in order to compensate the x variable, the 1 unit change in the x variable, the variable represented by the horizontal axis, you need a higher amount of change in the other variable, which is the y, which is the variable represented by the y-axis in our case. Okay. So this is the end of the little math part. I hope all of you have understood what we are doing. Again, if you have questions, I can answer those questions on the math. Now, today the question we will concentrate on is whether a person will decide to work or whether that person will decide not to work. And this decision will be like everything else. I mean, we have seen in microeconomics, when we are talking on agents, not companies, but the agents, the people we are talking about are willing to increase the utility level, which is kind of the happiness level or the benefit they got from their actions. So the utility level is the ultimate thing that will play a role in this decision-making process. So, how do we define the utility function in this case? Well, we have first in this case, we have two potential resources. We have time as the main resource. This time can be used for leisure activities, which give our individual a utility by itself. Alternatively, time can be used for labor activities, and that those activities might bring income, and the income might bring consumption for our individual, which will also increase the utility. Leisure and labor are composed of same letters, so basically these are the definitions from the book, so I keep them. L is the large L, capital L represents the labor, and the small l represents the leisure. And lastly, you need to spend some time for subsistence activity like cooking, cleaning your house, caring for your child. Those activities are represented by the letter small s. So, in addition to your time, you might also have a non-labor income that is coming from a source that doesn't require your time to be spent. So those are your resources, time and potential additional income coming from non-labor sources. So we will talk more in the next part. See you in the next part.